So every section has a unique ID number, and each elf is assigned a range of section IDs. As some of the elves compare their section assignments with each other, they notice that many of the assignments overlap. To try and quickly find overlaps and reduce duplicated effort, the elves pair up and make a big list of section assignments for each pair. Okay. For the first, well, this is clearly our input, so we're probably going to write a parser for this one. So for the first few pairs, this list means within the first pair of elves, the first elf was assigned sections 2 through 4, while the second elf was assigned sections 6 through 8. The elves in the second pair were assigned 2 sections. Yep. Okay, cool. This example list uses single-digit section IDs to make it easier to draw. Your actual list may contain larger numbers. Okay, cool. Some of the pairs have noticed that one of their assignments fully contains the others. For example, 2 through 8 fully contains 3 through 7, and 6 to 6 is fully contained by 4 to 6. No, Haskell, how's it going? Ethanol, the king. I like whenever I do Advent of Code, it's all about like learning new things. So like last year I did it in Rust, and this year I'm doing it in Kotlin. One thing I'm doing is doing it very coroutine style. So it's actually like super sick the way the code ends up, because you basically just have like these large concurrent like tree structures of like all the parallel work that needs to get done, and then you kind of like fold that up at the end. So you just write a few pure functions, and then you can like use this parmap unordered thing from Kotlin coroutines. So it basically looks incredibly functional because you're just like map, 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 and then do your fold. And you could like do this in in different orders or whatever. I'm not married yet, but I am engaged. So pretty cool stuff. So I think basically what we're trying to do is find... Okay, so basically we are just trying to find in these pairs, does one range fully contain the other, or how many of them? Okay, cool. So I think we're going to go parser combinator route because I think it'll be fun. And I just like really, yeah, no ring on my fingers yet, but that will come. Okay, so the parser combinators in Kotlin are actually pretty cool. I did some here, so I'm just gonna like copy an example. Oops, wrong button. Control Z, copy. Okay. So what we need to be able to do is parse one of these like sections, and then they'll be separated by a comma. So we're gonna these things are called assignments, so we'll call it assignment parser. And this is going to give us a parser not of rock paper scissors, but of something else. So we need to parse basically 2 numbers separated by a comma. So I don't remember if there's like integer parser, conbini. So let's see. Okay, so there's an integer parser. Yeah, perfect. So we're going to get the first... Oh, this is going to be a val. And this is going to be an integer. And then we're going to have character dash. And then val second integer. Okay, this is so loud again. Kind of an interesting song. Okay, so let's get this. Nice. And then basically we're going to have a pair from first to second. And then we will get rid of this. And that should return a pair of like longs, I guess, which is probably fine. I don't know if there's like another integer thing. What's a decimal? Floating point number, that makes sense. But I think here we can just use integer and be done with it, because that should get that. And then like there's a pair. What were they called? Pairs of assignments? Or like elves assignment parser, which is just going to be a parser of again, like first, but this one's going to be an assignment parser, and then we're going to have a character comma, and then val second, and another assignment parser, and then we should return basically first to second. That was the second time I wrote that. So you can see like this is just a pair of the assignment pairs. Now, one thing we could do instead is like, since we're going to have these things as longs, we could just like convert this directly into the thing that we want. And then that will just like propagate through to our second parser. Yeah, so I think we're going to do that because it kind of doesn't make sense. So there's probably like a sequence function of some kind. Sequence from two sequences. Yeah, I think this is like what we're looking for. Sequence of. Sequence yield. Yeah, this is like not what I'm looking for. I want like a integer range Kotlin is what I'm really looking for, right? Ranges and progressions. This is probably better for me. So we might be able to use this, which should work. We don't really need a step. So maybe we can just convert this to first ... second. And that's like a long range. Is it inclusive? Yeah, okay. It looks like it's inclusive because it says less than or equal to. So okay, let's look at a long range, because really I probably just want like a set of these things, because then I can just do like, does this other set fully contain the one? So I can probably just like convert this whole thing to set, I would bet, and then I have a set of long, which is exactly probably what I want. And then here I'll get basically the first and the second sets that I can just see if the first one's in the second one or the second one's in the first one, and vice versa. Okay, so next thing is we basically just need to like deal with these values. And so to do that, we basically have a path to our file. So the file is in input files, and then day for test text. And we need, I really wish I didn't have to like move to import it, and it just, that one. No, not that one. The colors were weird. I want this one. Yeah. Okay. And then for each of the lines, we're going to parmap. Just a second. Let's get this. This comes from flows. So I have these flows that basically emit lines or like windows of lines. And so I can easily just deal with flows of files and then like process them in parallel. Okay, so we have the lines, and then we're gonna parmap basically the elves assignment parser on it. It is like, oh, actually, that's not true. We're gonna dot parse it, and then also because this can like fail, we need to deal with that. So like, we have what is this? What is this about? Okay, so yeah, Combini is like, it'll let us parse these things, and basically you have two results. You have like a success, I think is what it's called. Hang on, success? No. Day 2 has an example. I forget what the two sides are called. It's got to be towards the bottom here. Parser result, okay. Nope, that's not what I wanted to do. Okay, so if we get parser result dot okay, then we need to I don't know why I keep closing this. Like, just move it over here so I can look at it later. Is okay, right. So is, and then if we get that, then res result, and then is parser result error. We'll just like throw oh, this is not like, this is like the line. And then I think we need to say val res equals like that. And then we can do this. We could like do it in a separate step if we wanted to, but I think basically we want to do this. And then these things are cold. So for now, let's just like make sure things are working. And we can use collect to like print basically what comes back. So we'll just like print whatever comes back, which is hopefully not an error and just a bunch of these. This requires flow preview. We'll just leave it like that. So I don't really understand the difference. There's like two versions of this where you can do like flow preview or this like flow preview class, but I don't really know the difference at the moment. So I tend to use this flow preview one because it just seems really easy. Oh, and then we want to say line like that. Okay, cool. So does this look neat so far? Any questions or comments? Okay, we're building. It can take a few seconds to do that. Okay, so there we go. So we have basically our sets to sets, and then what we're gonna do is just like check if they're subsets of each other. So val either is subset, and then here we're gonna get a pair of set of long, set of long, and then we're basically just going to return a like a boolean probably. Okay, and then this is basically, wait, what is this complaining about? It probably doesn't matter. So if p.first is subset, I'm not sure what the function is yet. Okay, what is this complaining about? True. Oh, duh. This is a function. Okay, there we go. So, basically, if p first subset set Kotlin. Okay, so contains all, and then it takes a collection. Perfect. Contains all p.second, or I don't know if how you write p.second dot contains all p.first. True. Else. Oh, then if we're just gonna do this, then we just like return this whole thing. So that will say, like, if either of these are true, then one of them is a subset of the other one, and then we'll just like fold on the sum of those things. So here we're gonna call if, or sorry, ac x. Oh, it's like a pair, and then we can just say well, we could also just first parmap this thing and then say either contains all it, and then that way all we have to do is like take the boolean and then say if b ac +1 else ac. And I probably need to do this. Oh. Import? Something like this. So one of the things that I've been doing for this whole process is like try and make things as parallel as possible. And so right, like if I separate either contains all into a separate parmap unordered, I think this implies that like I'm like working up the chain to finish all of the concurrency, and then like when I fold, I'm just like I am folding all the results as they arrive, kind of. I don't know exactly how all of this works yet. I'm still like learning about it, but I think it makes sense here to just separate either contains all, and then see if this works. So this should return 2 supposedly. Oh, well, I didn't print this thing. So val part 1 result equals, and then println part 1 result. Now we can play. Okay, so in theory this is correct, and like it's actually pretty clean, I think. I like that I'm using the parser combinators, and I think things look really nice. Okay, cool. So let's get this and then save this as, I think it's in here, here, and then day, whoops, day for text. Okay, and then here we just need to change this and then play. That's the right answer. Part 2. Okay, it seems like there is still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. Okay, so in the above example, the first two pairs don't. Okay, so instead of contains all, we just need contains, and that's basically it. Okay, so it's like instead of either contains all, we're going to use a different mapping function that like either contains. And then that'll be p pair set long set long boolean p dot first dot contains well, maybe it's like contains there's no contains any. Okay, we need to look at the, I don't know what's in here. Indices. Returns true. I guess you could just say like their intersection is not empty would be enough. Because contains doesn't take like what I expect. Like what I really want is like contains L or contains any. Distinct by, drop while. Filter. Yeah, so I think we just take their intersection, which I think is in here. Intersect. Yeah, perfect. Okay, so intersect p second is not empty, or, and then p second intersect. Well, wait, you don't have to do this, because if they intersect at all, p first any predicate. Yeah, we could do that too, but then we have to check like we have to do two set operations, right? Like we could just do one set operation by saying like if they intersect, then we're done, right? That would work, obviously. Like it's just a slightly different way to do it, and the predicate would basically just be x dot element. Where is it? Let's just do it because I want to like keep practicing both. Oh, there's like tons of stuff in here. Holy cow. I think it was element. Oh my gosh, it says element like 1,000 times. So I don't know how to find specifically element there. Oh, it's right here. Wonderful. Oh, it wasn't element then. It just contains. Okay, so it would be like, instead of this, I think an equivalent way to write this would be p.first.any, and then we want a lambda, which is like x dot contains, or no, sorry, we want actually p dot second dot contains x, right? That's the alternate way to write it, I think, if we want to. I have no idea which is faster. Like, it seems like the set intersection would probably be faster because I have no idea. If you have any like logic about that, please let me know. Also, how's it going? I don't think I recognize your name. Okay, so anyway, that's like that, and then all we have to do is replace like this version, so we can do part 2, and we'll have a part 2 result, and then we're basically doing the same parser combination, or parse section, and then instead of this, we're just doing either contains, and then we fold all the booleans that are true, and then part 2, like so. And I think this is just right, so I'm not even gonna like try to think about it too much. Let's just see if it works. Yeah, perfect. So so that's day 4. that was actually like pretty easy. So anyway, if you have any questions, let me know. Uh, we can talk about them. Uh, I just absolutely love doing parser combinators for this stuff. Like it's just so pleasant to work with. Um, like this parser combinator library is like really nice. Big fan. I would love to be able to like I wonder if there's a quick way to see the concurrency. So like benchmark or like see I don't know, Kotlin concurrency view. I don't know what to like this is this visualizing. What is code sync? Oh, but that's like a better way to say it. Uh visualizing concurrency in Kotlin. Okay, well this comes up. Let's hope it doesn't like destroy me. Okay, this is like a whole talk. Maybe we can view the slides. Okay, I know how to do the coroutines. So what we want to see is like, how does it look like? Let's visualize. Big black box. Nice. Okay, there's really nothing there, unfortunately. What is this IDE called? Idea in IntelliJ? What's this? This doesn't look very promising. But yeah, I don't really know how to do this yet. So it would be really cool if I could like visualize the concurrency tree basically that it's building, and then like analyze how it was run. Maybe instead of graph, we'll write like analyze. Detect concurrency issues. Okay, what does this do? It's a tutorial. Interesting. Debug concurrency test main. Run with CPU profile. Okay, maybe there's like a okay. This seems relatively harmless. Okay. So profile. Profiler. CPU samples, memory allocations. I'll be honest, I have no idea what I'm looking for. Okay, method list. C2. Like, it's kind of unclear to me what to take out of this. And, like, if anything is actually happening in parallel. Does anyone know how to read this? I don't actually know. Okay, dispatch task. I don't really understand what I'm looking at, if I'm honest. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I mean, I have 12 cores. Is that like, I'm pretty sure? No, I have more than 12 cores, so... I need to learn how to do this. I don't really know. C1. Because, like, this looks like almost initialization stuff. And this is, like, where things actually started. Is that, like, what I'm supposed to read here? Ooh, this looks interesting. Okay. Okay, let's go here. So there's something kind of tricky here because I think there's well, what are these? Nah, I have no idea how to read this at the moment. if I'm honest. Okay. Yeah, I don't know. I don't have any idea. Anyway, it feels pretty fast. So, also, I think that I can just remove this, by the way. And it's this exactly the same. Is that correct? Yeah, I think so. Okay. Is this like unused? I don't think this is being used. Okay, it is. Okay, cool. I'll go through this solution one more time, but I don't think it's like very, very easy. So an assignment is like like 1 to 2, and so we just basically convert 1 to a set to do like set operations. Cool. Easy. Easy. And then like what did they call it? They had like a name for it. Just overlap. Actually, is this even right? Yeah, it is. Part 2. So far we've only really seen set operations inside of Advent of Code, which is kind of interesting. And so yeah, I see a few people popping in. So this is just the business logic for part 1 and part 2, and then we just do some like parallel mapping to parse the lines, and then like do the business logic, and then fold the result into an accumulator, and that's basically it. So there's some interesting stuff here for anyone that's not done a ton of Kotlin. If I hold this fold off, literally nothing will happen because flows are cold. So if I don't do like a collection operation, these will both be null, which is kind of interesting. So you can, and also you see how I don't fold, it all of a sudden becomes redundant suspend. It's because I literally am not doing anything. And so if I play this thing, it's just going to print, like, yeah, like I don't know what this thing is, because it's just like some flow that I haven't like collected. So we have to put the flow or the fold at the bottom. So there's kind of like two options. You can either, why is this so large all of a sudden? You can either flow or you can collect. So like if you don't need to combine all the results, then you could use a collect function, which would just like give you each element, and you could like collect them into a list or like whatever you want it to do. Doesn't really matter. So, but you need to do something with them. Okay. and then this should like actually do the concurrency now and give you a result. I've been reading about the concurrency model, and it's actually pretty sweet, especially the stuff around like exceptions. I mean, because it's like a structured concurrency model, it's basically just a huge tree, and then each like concurrent piece is just a state machine that like has enough of the state to figure out what to do next. And like the way the suspension works is kind of cool too. None of the functions that I'm applying here have any ability to suspend, but I think I could make them do that if I wanted to. It doesn't really matter in this case. So I think like if you really needed to control your suspension, there's like a yield function, which basically allows you to do that. We couldn't do that here. Like if we wanted to make this suspend, I think we would just do like, we could do yield. This has to be run, I guess. Actually, we don't want it to be run. We probably want it to be coroutine scope. And this like yield thing will allow you to suspend this if it needed to be suspended for some reason. This one doesn't, so it can be like just completely pure, I think. So I'm just gonna delete this, but that's like one way to make suspendable pure coroutines. There's yield, and then there's like ensure is active, and that's so these kinds of things are like useful when you have actual parent-child relationships, which we don't have in this case. It's just like everything kind of happens one after another, so you don't really need it. But if we started canceling these coroutines, then we would really need to like think more carefully about this. But we really don't. Does anyone have any questions about the code? See a few people drop back off, so I don't really have anything else I wanted to work on.